Now let's start thinking about our functions, our trigonometric functions, as functions themselves. So thinking of functions like f of x and the properties that we have seen with those functions now being translated to our understanding of trigonometric functions. So let's look at a warm-up problem where we have 3 angles given to us and we're supposed to sketch the angles and find the sine of each angle. So let's look at theta equals 3 pi over 4. 3 pi over 4 is not quite pi, so we are looking at an angle in the second quadrant, and the reference angle is pi over 4. So we know that the sine of 3 pi over 4 will be the same as the sine of pi over 4, which is root 2 over 2, and since it's in the second quadrant, it's positive. So now as we look at theta equals 11 pi over 4, it might be helpful to think of it 11 fourths as 2 and 3 fourths. So we have 2 pi and then 3/4 more pi. So again, the reference angle is pi over 4 and we land in the second quadrant. So the sine of 11 pi over 4 is again root 2 over 2. Now as we look at 19 pi over 4, it'd be helpful to think of 19 fourths as 4 and 3/4. So as we go ahead and sketch that, we have 2 pi, 4 pi, and then 3/4 of a pi. So we land in the second quadrant, yet again, with sine of 19 pi over 4 is equal to, our reference angle is the same as before, and we're in the same quadrant as before, so therefore we end up with the square root of 2 over 2 in each one of these circumstances. You can imagine that as we add more and more revolutions, as we keep adding 2 pi in each one of these situations, we'll continue to end up with a coterminal angle in the second quadrant, and we could even go clockwise and subtract 2 pi and just go revolutions in the clockwise direction, and we'll always end up with square root of 2 over 2. So let's look at another type of function. Let's look at the tangent function, and here again we have several angles. To illustrate this one, I'm going to draw all our angles on the same set of axes. So if I'm to sketch pi over 3, that's a first quadrant angle. It's a third of a pi. So there's pi over 3. So we know that tangent of pi over 3 equals the square root of 3. Now if we're going to look at 4 pi over 3, we might want to look at 4/3 as 1 and 1/3. So we have an additional just 1 pi So if I add 1 pi onto pi over 3, I get 4 pi over 3. And you'll notice that the reference angle here is pi over 3. And tangent of theta is positive in the third quadrant. So tangent of 4 pi over 3 is the square root of 3. Now, if we go ahead and look at our next angle, 7 pi over 3, and we want to find the tangent of 7 pi over 3, I will say, okay, 7/3 is 2 1/3, which means that to my 4 pi over 3, my 1 1/3, I just have to add pi. So add 1 pi, and we obtain an angle in the first quadrant that has the same reference angle, and so therefore we have the square root of 3. And then we have 10 pi over 3, and 10 pi over 3 is 3 1/3, which is just an additional 1 pi. So we end up in the third quadrant with the same reference angle. So tangent of 10 pi over 3 is the square root of 3. So what's the connection between the angles here? To get from one angle to the next, I'm just adding pi units, and we obtain the same exact output for the tangent function. So whenever a function repeats output values on a regular basis, then we call that function periodic. And the period is simply the distance between inputs that yield the same output. It's the smallest distance that would yield that output. So for example, we saw in our first warm-up that every 2 pi units we have the same output for sine. So 2 pi units later, we would have the same output for sine. And the same is true for cosine functions, cosecant functions, and secant functions. But you'll notice in the second warm-up that we did, the distance between our inputs need only be pi units. And so that's true for tangent of theta and cotangent of theta. So let's apply this to sine of 405 degrees. There's nothing wrong with doing this the same way that we had been doing it in the previous videos, using reference angles and sketching our angle, but this may or may not shortcut the process for you. So let's apply this property, sine of 405 degrees. So let's just simply look at the fact that 405 degrees minus a revolution is going to yield for us 45 degrees. So sine of 405 degrees is equal to the same thing as sine of 45 degrees plus 360 degrees. But this is sine of 45 degrees, and this 360 degrees is the period for the sine function. So if we add a period to our input, then the output is going to be the same as the sine of 45 degrees, which we know to be the square root of 2 over 2. In the next example, we're dealing with the tangent function, so we can subtract off increments of 180 degrees, the period of the tangent function. So let's go ahead and take 600 degrees minus, and now we know that we can at least subtract off a full revolution, and that will yield for us 240 degrees. So that's like subtracting off 2 periods, but we can still subtract off another. So 240 degrees minus 180 degrees is going to yield for us 60 degrees. So this means that 600 degrees is equal to 60 degrees plus 3 times 180 degrees. So the tangent of 600 degrees is tangent of 60 degrees plus 3 periods. And so tangent of 600 degrees is nothing more than the tangent of 60 degrees. Tangent of 60 degrees is the square root of 3. So let's look at cosecant of 17 pi over 4. So for 17 pi over 4, let's go ahead and look at 17/4 as a mixed number, which is 4 and 1/4. So you can think of that as 1/4 plus 4. So we know that 17 pi over 4 is pi over 4 plus, well, 4 times pi, which is 2 times 2 pi. So the cosecant of 17 pi over 4 is the same thing as the cosecant of pi over 4 plus 2 times 2 pi. But 2 pi is our period for the cosecant function. So we have 2 periods. And it doesn't matter how many periods we add or subtract, the cosecant will still be the same as cosecant of pi over 4. So cosecant of pi over 4 we know is the square root of 2. Now let's look at the tangent of 25 pi. So remember here that the period for the tangent function is pi. So as we look at tangent of 25 pi, we know that 25 pi is 0 plus 25 times pi, our period. So the tangent of 25 pi is the tangent of 0 plus 25 times the period. Well, that means all those additional periods just land us back at the tangent of 0. And the tangent of 0, that's a quadrantal angle that we should have memorized, is 0.